We're always told that bigger is better, that more complex technology is always the way forward. But what if, for some of the world's most critical problems, the smartest answer is actually the simplest one? Let's dive into a real world example where this very question is changing the future of our planet's energy.
Okay, so here's the deal. The whole world is going green, right? We're shifting to solar and wind, which is fantastic news for the planet, but it's creating a massive headache for the people who manage our power grid. And you might be wondering why. Well, it's because the very nature of energy is being turned on its head. Think about it. For a century, our grid was built on fossil fuels. Yeah, they're dirty, but they were predictable. You need more power? You just burn more coal or gas. Simple. Renewables, though, they're clean, but they're wild. You only get power when the sun decides to shine or the wind feels like blowing, which, as we all know, is not 24/7. This creates this huge, delicate balancing act. And that's where the smart grid comes in. It's the modern upgrade our system desperately needs to handle this new, kind of chaotic reality. It uses all this advanced tech to intelligently manage those wild swings in power, trying to match that unpredictable supply with our constant demand. So how does a smart grid get smart? Well, to prevent blackouts, the people in charge can't just react to changes in power. They have to see them coming. They need a crystal ball to predict the future. And for a modern grid, that crystal ball is artificial intelligence.
The specific job here is called load forecasting. All that really means is using AI to predict precisely how much electricity a home, a neighborhood, or an entire city is going to need in the next hour or day or week. Getting this right is absolutely crucial for keeping the lights on.
And this is no simple task. The AI has to crunch a ridiculous amount of data. It's not just looking at past energy use. No. It's looking at that, plus weather forecasts, the time of day, whether it's a weekday or a holiday, even what the economy is doing. It's like solving a hugely complex puzzle that's always changing. So to solve this puzzle, engineers brought in the heavyweights of the AI world. We're talking about incredibly complex deep learning models, things with names like LSTMs and transformers. These are the state of the art, built to find the tiniest, most subtle patterns inside mountains of data. And these models are amazing, provided you have those mountains of data. But what happens when you don't? What about when you have very limited information to go on? This is where our story takes a really fascinating turn.
Let me paint you a picture. It's called an energy community. It's basically a group of homes or local businesses that team up to produce, manage, and share their own power, usually with solar panels and a big shared battery. It's a huge part of our green future, but these new communities have a big problem. They have almost no historical data for a fancy AI to train on.
So researchers decided to test this, and what they found was pretty remarkable. With only a couple of months of data, the big, complex deep learning models were actually less accurate. They made more mistakes than a much simpler model. It was only after about a year of collecting data that the complex models finally pulled ahead.
And here's the finding, right from their research paper. For a brand new energy community with less than 6 months of data, a basic model, one that just assumes this Tuesday will be like last Tuesday, is better than a state-of-the-art AI. It seems the complex models, without enough information, just get confused. They overthink it. Okay, so forecast accuracy is one thing, but does it really make a difference in the real world? Does a slightly better prediction actually translate into you saving money? Well, the researchers wanted to know. So they ran a simulation. They created this virtual neighborhood of 50 houses, all sharing one big battery. The goal was simple. Use the AI's prediction to charge the battery when electricity from the grid was cheap, and then use that stored power when grid electricity got expensive. Better predictions should lead to bigger savings. And the results? The best deep learning model, the LSTM, helped the community save an average of 8.06% on their energy costs. Pretty good. But then they ran the same simulation with a much simpler model, a classic called K-nearest neighbors. And the savings? 8.01%. The difference was almost nothing. So here's the kicker. For this critical, real-world job, a simpler, more robust model that needs way less data and less computing power achieved basically the same financial outcome. The extra complexity of deep learning just wasn't worth the hassle. And this discovery really pushes us to think beyond just being accurate. As AI gets woven into our critical infrastructure, the challenges change. The next big thing for Grid AI isn't just about making the right prediction. It's about us being able to understand it and about protecting our data.
And there are two big hurdles here. First, there's the black box problem. These complex models can be so mysterious that even their creators don't know exactly why they made a certain decision. Can we really trust that? So a whole field called explainable AI is working on that. And second, the privacy problem. Your smart meter data reveals so much about your life. When you wake up, when you leave for work, when you go on vacation. That's really sensitive stuff. But a brilliant solution is emerging for the privacy issue, and it's called federated learning. The old way meant sending all your private data to a central server to train one big AI. The new way completely flips that. The AI model is sent out to learn locally on your device using your data. Then only the anonymous lessons it learned, not your data itself, are sent back. Your private information never leaves your home.
Which brings us right back to where we started. This journey into the smart grid suggests a different kind of future for AI. One where success isn't just about raw power or complexity, but about being efficient, trustworthy, and respecting our privacy. Perhaps the smartest AI is the one that knows when it's best to just keep it simple.